Number 9, or rather number 11, sorry about the typo there, it should say number 11, says the path of a tennis ball rolling off an apartment patio can be modeled by the parametric equation x of t equals 3t, y of t equals negative 16t squared plus 40, where x and y represent the horizontal and vertical height in feet after t seconds. So really I guess this should say horizontal distance and vertical height in feet after t seconds. Anyways, the first part of the problem says, what will the height of the ball be after 2 seconds? Well, our y equation represents height, so I'm going to substitute the 2 into the y equation for t, because again, t is representing the amount of time in seconds, so it makes sense. So I'm going to write y equals negative 16 times 2 squared plus 40 equals, plug that in our calculator, we get negative 24 feet. Now, this number is kind of funky. I mean, we can't have a negative height. I mean, basically it hits the ground, and what's going to happen? Is it going to just keep going to the ground until it gets to negative 24 feet and stop? No. After 2 seconds, it's been on the ground already, maybe for a second or so already. So what this answer really means is that, or implies, is that the height after 2 seconds is 0, because we can't have a negative height. Okay, so don't let them trick you by putting a number in there that doesn't really make sense. Part B says, when will the tennis ball hit the ground? Show the computation that led to your answer. Indicate units of measure. You may use a calculator to check this, but work must be shown for credit. So again, I'm going to work with the y equals equation because I'm talking about height. I want to know when the ball hits the ground. So basically I'm going to use the y equation, but I'm going to solve for t, because when it says when, I'm talking about the amount of time it's going to buy before it's hit the ground. So what's the height when it hits the ground? Well, the height is 0 after it hits the ground. So I'm going to write down my equation, and then I'll show what I plug in. Again, the height, or the y value, is going to be 0 when it hits the ground. This is pretty nice because we don't have to worry about doing the quadratic formula, because we don't have a squared. I'm sorry, let me erase that. We don't have to do the quadratic formula because we don't have, we don't have a quadratic that's in the form of ax squared plus bx plus c equals 0. If we had this situation, we'd have to use a quadratic formula, but I don't think our final exam has anything involved in quadratic formula, so we're not going to worry about that right now. We can solve this a lot easier by simply subtracting 40 from both sides, so we get negative 40 is equal to negative 16t squared. Divide by negative 16 on both sides, we get t squared is equal to 2.5. And then just don't forget to take the square root. So what does all this mean? That means that the t, after we take the square root, is plus or minus, don't forget about the positive and negative, square roots of 2.5, which comes out to approximately plus or minus 1.58. Now I said don't forget about the plus or minus because some problems you do need both of those. But In this problem, in real life scenario, it doesn't make sense to have a negative time. So really all we're worried about is the positive version or the positive answer. So we're only worried about the positive 1.58 seconds. Again, for other problems it might make a difference, so be careful. Now, part C, we want to use our answer in part A to figure some things out. So let me bring that up. It says using your answer in part A, how far from the edge of the patio will the tennis ball hit the ground? Show your computations, yada yada yada, and we can go back and use our calculator to check. So at the very end of this problem, I will go back and plug it into the calculator, remind us how to do that. But again, when our exam, we need to show our work. So that's what I'm focusing on here, how to do the work by hand. Okay, so anyways, we want to know how far in the horizontal direction, or how far from the patio it hit the ground. So what I'm going to do is use the x equation this time. I'm going to write x is equal to 3t. X is equal to 3 times 1.58, because after 1.5 seconds, 1.58 seconds, it's hit the ground. So I'm just going to multiply that by 3 to see how far from the edge of the patio it went. So we get a horizontal distance of about 4.74 feet. Part D says express the parametric equation as a single rectangular equation by eliminating the parameter. So basically what that means in fancy math lingo, by eliminating the parameter, sounds kind of fancy, but all it really means is like get rid of the t. Condense those two equations, the x and y equation, to simply one equation. So what I'm going to do is I'm going to jot down, to remind everybody what our original equations were. And I'm going to solve the first equation for t. So if I solve the first equation for t, that means that t is equal to x over 3. I just divided both sides by 3. I'm going to take this value here and I'm going to substitute it in to right here. So now what we'll be left with is just one equation with only two variables present. So rather than having two equations with three variables, we'll only have, again, one equation with two variables. So anyways, we have y equals negative 16 x over 3 squared plus 40. Do a little simplifying because sometimes they will ask you to do that, or on multiple choice answer you might get this, you did all your algebra right, but they give a more simplified answer, so I'll show that just in case. So it would be x squared over 9 plus 40. Remember to always do your exponent before you multiply the 16 in. So anyways, we get negative 16x squared over 9 plus 40. So that's really as simplified as you can get it. So as I promised, I said that we could go into the calculator and we'll check our answers. So since these are parametric equations, I'm going to change my mode to parametric. It doesn't really matter if it's in radian or degree because we're not using cosine, sine, or tangent or anything like that in our equation, so I'm not even going to bother changing that. I'm going to go to y equals, I'm going to plug in both of my equations. Okay. Now be careful, if you ever get an error message, this is really common, I see this all the time. Sometimes people put a minus sign in front of here, and your calculator doesn't realize that you just mean negative. So again, it's a subtle difference, but if I put a minus sign down here, you can kind of compare and see how big this one is compared to the little negative sign. Anyway, it's just a little side note, so just be careful that you don't do that. Okay, so I think I have both my equations plugged in correctly. If I think about this realistically, go on my window, I'm going to change a few things around here. Again, Tmin and Tmax are just the time. Now, the tennis ball in this problem hits the ground. It doesn't even take 2 seconds to hit the ground. It hits the ground after 1.58 seconds. So I'm just going to change this to like 3. That's plenty large. I mean, we're going to actually see it, go to negative values, but it really doesn't make sense. The T step is just how often it graphs a point. So usually a smaller T step is going to give you a nicer graph. My X min, I'm going to set it 0. So that's like right at the the ledge of the patio. My X max, not going to go very far. We said it only went 4.74 feet. So I'm going to change that to, I don't know, I'll change to 8. Be plenty. And let's change the Y min and max. Well, starting height, maybe you can recognize from the equation, is 40. And that's just a matter of remembering those formulas a little bit, kind of just a flashback to that. Anyways, I'm going to put about 50 in, a little bit higher. The Y min, I'll just show some negative values. I know we're not really concerned about those. But let me just do, I don't know, negative 15, negative 20, something just to show the x-axis. If I hit graph now, we're going to see the path of the ball. Okay, and that makes sense. The ball's coming off the patio, and it's got a little bit of velocity when it starts off, so it flies off, and then boom, it hits the ground here. So if I hit trace, I can trace along my equation. And for whatever reason here, I'm having a little bit of an issue. Oh, there we go. Okay, you should see T, X, and Y. Okay, let's try that again. So you might have to scroll up or down to get to the right spot. Another thing to check if you have an error in your calculator is hit second stat plot. You can turn this off by entering into it. Anyways, going back to the graph, hit trace. I can trace along this, and we can see that, okay, it hits the ground at approximately 1.6 seconds because that's when the ball turns from a negative value. So it goes from a positive to negative, so it goes into the ground at that point. Okay. The other things you can check are, let's see, we can check our answer to part A, to part B and C. So we just did B. So if we look at the X value here at when it hits the ground, it's approximately 4.8, and we had by hand we got 4.74, so it's pretty close. So again, this is just a way to check your answers.